Now we're going to discuss section 3 of chapter 10. Section 3 is about matched samples as opposed to independent random samples that we discussed in the previous videos. In matched samples, what we have are two samples taken from the same sample subjects. Observation 1 is made prior to an event from a sample subject, and observation 2 is made from the same subjects as sample 1 after a given event. For example, suppose if you want to test the efficacy of, say, a diet program, so you may want to weigh each subject before they go into the program and then match each observation with the weight after the completion of the program. So this is the reason why this is called match sample, because each observation is matched to another observation from the other sample. So an observation in one sample is matched to a corresponding observation in the second sample. For this reason, the two samples will have to be of the same size, because for each observation in one sample, you must have a corresponding observation in the other sample, and that's why it is called match sample. So when you have a match sample, the sample sizes are equal, okay, n for sample 1, n for sample 2. Then we have one observation, let's call that x sub 1I, it's the ith observation from sample 1. Then we have x sub 2I, so the ith observation in sample 2. When these two are matched, these two are taken from the same subject, same sample subject. So then we can define a sample difference between the two sample observations. So x sub 1I minus x sub 2I is the difference, the ith difference in the samples. So in this way, we can convert the matched samples into one single sample of differences. So originally we have two samples which are matched, and now we have reduced it to a single sample of difference, and we define mu sub d as the average of those differences. Then sigma sub d is the standard deviation of those population of differences, and we can compute a sample mean of the differences, sum all the differences, divide by n, and we can compute sample standard deviation of the differences. So instead of x, we use the d's. So now we essentially have a single population case. Instead of x, we have d. So confidence interval will be, instead of x bar, we have d bar, and then the t table value, s sub d over square root of n, the degrees of freedom equal to n minus 1. And the hypothesis testing is going to be similar to the single population hypothesis testing. The three types of hypothesis, and the test statistic will be t d bar minus mu sub 0 over standard error of d. And then we will have the two t distribution or t functions for the p value, the degrees of freedom being equal to n minus 1. We'll use the Excel data analysis command for match samples to generate all of this information.